The purpose of this video is for you to be able to predict formulas using Lewis dot diagram structures. Now, Lewis dot diagram structures are mainly used for covalent molecules because covalent molecules are where the valence electrons are shared, and Lewis dot diagrams show them being shared because they're going to fit the pieces together like jigsaw puzzles. And the objective is really like, with hydrogen and oxygen, what would the structure be? How do I arrive at H2O? All right. Now, you really need to start with your formula or elements involved, or ingredients, if you will. And from those, you need to consider what type of bonding is going to occur. And that's where you're going to need to use your periodic table and the element's position to figure out which is going to be. This lesson is when I'm dealing with covalent molecules or polar covalent, and I'm going to use Lewis dot diagrams. Ionic is going to use something known as oxidation states. And oxidation states are the charges that they get when they gain or lose. And we'll get into that. It's a totally different lesson. The first example is hydrogen gas. And by its name, it's implying that hydrogen gas is just hydrogen. So what would the structure be of this molecule? The first step is to figure out their Lewis dot diagrams. So hydrogen is this, one dot. It's in the first group, so I've got one dot. Now, it doesn't matter which side you draw it on. And then I'm going to jigsaw for 8. Now, hydrogen is the one exception to this. It only needs 2. So how many hydrogens do I need so that I get my outer shell completely filled? In hydrogens, it is 2. So I'm going to need another hydrogen. And I'm representing its valence electron with an X. Then these two are going to link.
To the office, please. Liberty Roth, Eric Burdett, Carter McLean, Sarah.
Now, each one is sharing 1 with the other, and they each have 2. You count hydrogen 1, 2, all right? And therefore, I have a full outer shell. Another way you can do this is a stick. And this stick represents 2 bonding electrons. Now, the next example is hydrogen and oxygen. Hydrogen is still going to have 1, and oxygen is going to have 6. All right? Now, I'm going to jigsaw them together and get this. All right? Now, if you'll notice, hydrogen has got its 2 that it wants, but this oxygen doesn't have what it needs. So what you're going to do is you could add another one of the elements involved. You could add hydrogen. And you would get this. This is water. If you add in an O, I'd get this, and then I could add another H. This is water, and the formula is H2O. This is hydrogen peroxide, and that's H2O2. All right? Sometimes when you do these problems, you're going to have a formula. And the formula for carbon dioxide is CO2. What does it look like? All right? So the first thing I'm going to do is draw my Lewis dot diagram structures. My first step, like I just said, would be to draw my Lewis dot diagram structures. All right? Group 16, 6, 14, 4, 6. All right? Now I'm going to jigsaw them. So Now, I have jigsawed them together, but the carbon in the middle only has got 1, 2, 3, 4, 5, 6. And the oxygens only have 7 on either side, so that's not good. What will happen in this case is you'll form double bonds. Elements in group 14, 15, and 16 can form single, double, or even triple bonds. So now each one has got its full octet: 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. All right, that's Lewis structure, and I could also do this, the stick structure like that.